This video is on bisection in Microsoft Excel 2010. For this bisection video, I have an example problem. The problem is 0.5 times e to the x minus 5x plus 2. With this function, we need to find the zero of it, or where it crosses the x-axis. I know that there are two of them. One is between 0 and 1, and the second is between 3 and 4. We're going to try and find the one between 0 and 1. To set this up, we need to do the same thing as we would if we were doing it on paper. We need to have two initial guesses. I'm going to call them guess A and guess B. Guess A, I'm going to pick as 0, and guess B is going to be 1, since I'm aiming for that first root. Now I need to have the midpoint between them, which is C. So 0, 1, and halfway between them is 0.5. Now we need to plug each of these into this function and find out what their values are. So f of A, f of B, and f of C. So f of A equals 0.5 times exp, and it's exp to x, which in this case is just 0, minus 5 times our guess A plus 2. So the value is 2.5. I can use the fill handle to go ahead and fill in f of B and f of C. So now we need to find out what our new A is. And to help visualize this, I've got a drawing going. So our guess A is 0, guess B is 1. So our guess A here, our guess B is here, which means our midpoint is about here. So our midpoint is a positive number. At 0.3, guess A is a positive number at 2.5, and guess B is a negative number, negative 1.6. As you can see, both A and B are too far off the screen. So what we want to do with bisection is to get closer and closer to our 0 here by trimming off the excess on the end. We can tell by looking at this that we need to get rid of the A and replace it with the C, since the C is much closer to the 0 than the A is, and they're both still positive. Since the B is negative, and the only negative, we're going to keep that the same. So how do we translate this decision into the code needed on our Excel spreadsheet? Translating this into the code, we need to find out mathematically here if the sign of C, which is our midpoint, is the same as the sign of A or the sign of B. If it is the same as one of them, then it replaces the original. So for example, we would have to use an if statement. If the logical test, which in this case is that times that, is greater than or equal to 0, then this becomes its new value. If not, it'll keep its old value. So what this is essentially saying is if f of A times f of C is greater than or equal to 0, so if they're the same sign, then this becomes C7. Midpoint would replace guess A. If they're not the same sign, then guess A will remain the same. We need to do the same for this test. If f of B times f of C is greater than or equal to 0, then midpoint will replace guess B. If not, guess B will remain the same. And the midpoint is just finding the location between the two, so we can use the fill handle to fill that in. As you can see, guess A is now 0.5, guess B remains the same as 1, and our new midpoint is 0.75. The three of these we can just fill down. Now we have an entire row here of referencing. So if we want, we can fill down a bunch of rows until we get a satisfactory answer. But at this point, we need to decide how we want to finish this. Do we want to go a certain number of times, for example, iterate it 20 times, or do we want to go until it reaches a specific accuracy? I'm going to go ahead and just run this about 10, 20, something more times. I'm going to make this simple and just go ahead and get this to recalculate. Here you can see that the next guess had our midpoint as a negative value. So the 0.75 became guess B, and we have a new midpoint. If I recalculate it again, it'll be 0.625 for our guess B. And the gap between guess A and guess B is getting smaller. So I'm going to create another value here that's just the gap between these two. That way we can see how close they're getting. Now if I take this and fill it down another one, and again, you can see how small that error is getting between them. I can continue to do this until either these stop changing or my error, which is this final column, gets within a specific range. So let's say I want my error to be less than 0.00005. And I'll just have a simple test here. If that is less than 0.00005, then I'll have it give a 1 for true or a 0 for false. And until it shows a 1, I know that it hasn't reached a high enough accuracy. And here, we've reached a 1. So I know that this point has already been below my estimated error. So this means for my calculation here, I can take this midpoint value, which is 0.5783, and say that is roughly the root of this function. You can do this, if you like, and switch this to 3 to 4 rather than 0 to 1, and have it run again, and it'll reach the new point at 3.4018 is the second root. And it'll just recalculate when you change these. So I can change this to 3.5, and it'll get there faster by 1 step. If I change this to 3.3, then it'll get there faster here. It's up to you how you ultimately set this up, but this is a basic bisection.